So I'm looking for things that if I go to write it down symbolically, and by symbolically I mean represented with operations and numbers, variables if I need them. So I'm looking for things, as I look at these three patterns, there's two different things that I notice about them. One thing that I notice about these patterns, after I totally gummed it up here, is that each pattern has a perfect square as part of that pattern. Do you guys see the square that's there? Mm-hmm. This is not, by the way, the only way to approach this. So I see a square. That's staying consistent between each pattern. The square is getting bigger each time, but each of these in the pattern has a square. What else do you notice each pattern has that is the same?
It's each.
Mm-hmm. We've got... I have these two little purple squares that have been tacked on. And on each of these, I have two little purple squares that have been tacked on. How would I represent symbolically that each time I make a pattern, it has two extra random squares attached to it? Add 2 or plus 2. That is this part right here, this plus 2. That's representing those two purple squares. So far, so good? Then I have to find a way of representing how many tiles there are in each one of these teal squares. I can't just do plus something again because the squares keep getting bigger. And I want to find a way of being able to quickly determine how many little tiles there are in each square. How many little tiles are there? I'm not talking about the purple ones. I'm just looking at the teal here. Just one little tile. What about this one? 4. This one?
9.
Did you guys count 1, 2, 3, 4, 5, 6, 7, 8, 9 on this one? What's a faster way to look at it and be like, there's 9?
3 times 3 is
3 times 3. So let's take that idea and extend it backwards. If this one is 3 times 3 tiles, this one would be 2 times 2, 1 times 1. I'm doing length times width, and then we're going to add those 2 tiles on the end. And each time we look at the length and the width, this is the first one in my pattern. Here's the second one. Here's the third one in the pattern. I'm noticing that the length and the width is always matching up with that number. Third one in the pattern, length and width are 3. Second one in the pattern, length and width are 2. First one in the pattern, length and width is 1. Is that making sense so far? So I can use that knowledge to help me write an expression and to find the number of tiles in the 65th figure. If the first one in the pattern has a length and width of 1, and the second one in the pattern has a length and width of 2, the third one in the pattern has a length and width of 3, in the 65th pattern, 65 by 65. So I can do 65 times 65 to find how many little tiles there are in the square part of it. And then we said that every single one has what tacked on it? Plus 2. So I do 65 times 65 to find how many tiles in the square, plus 2. Does that make sense? And so I could represent that as n squared, where n is where I am in my pattern, or I could do n times n, length times width, plus those 2 on the end. So I can use an expression like this. And using that, could you guys tell me how many little tiles it would take to do the 112th one in this pattern?
You do 100 times 112.
What would it be for the 112th one?
25.
Yep.
I get it now. Yeah.
12, 5, 4, 6. Lots and lots of tiles. an excessive amount of tiles. Do you guys want to look at another pattern like this, or do you want to do one of the other ones on your page? Another pattern?
Yeah.
Absolutely. Yeah, I've got a different one. Let me pull up a different pattern. We'll see what we can do with it. Let me find a good one for us.
Oh, I thought that was hard.
Yeah.
Oh, yeah. It's like,
I don't know what.
My heart dropped.
I don't want.
Okay. I'm gonna have to snip it and then put it on that screen. But I found a good one for us to look at. It is very similar to the one that we were just looking at. Yes. If I can make it bigger. All right. That's the one we're looking at there. Let's see what we can do as far as finding a pattern here. Find the pattern, and then I want you to find how many flowers there are in the 43rd. Mm-hmm. Does anything stand out to you that's staying the same each time?
The two?
The 2. There's always these 2 right here. And I can even see it right there. That one has 2 also, right? All right, so I've got like this nice rectangle pattern going on and then like just 2 extras. How do I represent those 2 extras? Plus 2. Love it. All right, so it's going to be something plus 2, something plus 2, plus 2, plus 2. Okay, so now I need to find a way of representing the rectangle.
Can we do it?
Can we do what?
Is it going to be like the number one, like n?
We're going to end up with an n value, yes. How could I find a way of describing how many flowers there are without 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like multiply. What can I multiply to find it quickly? Remember what shape it is. It's a rectangle, right?
Yeah, so it's length times width.
Length times width. So I'm going to do length times width, and then we're always plussing 2, right? All right, so let's try to look for a pattern with the length and the width. Length and width here. 4 times 8. So 4 times 8 plus 2. What about for the third one in the pattern?
3 times 6.
3 times 6. Yeah, 3 times 6 plus 2. What about this one?
2 plus 4.
2 times 4. Mm-hmm. Plus 2. 2 times 2. Oh, 2 times 2 for the whole thing, but remember, I'm ignoring the 2 that I see staying the same. 1 times 1 times 2 plus 2. So that red plus 2, that's staying the same. So that's going to become part of my expression because that's always staying the same. So now I'm looking at this 1 times 2, 2 times 4, 3 times 6, 4 times 8. This is where my eyes are going next because that's what I need to figure out how to represent symbolically. Do you guys notice a relationship between the numbers that we are multiplying together?
It's going up 1 time.
One's going up by 1, one's going up by 2.
2, 4, 6, 8, going up by 2. 1, 2, 3, 4.
Going up by 1.
Going up by ones each time. Do you see any relationship between either one of these numbers and where we are in the pattern?
They're double of each other.
They're doubles of each other, yes. I'm trying to relate it back to this because I want to find the 43rd pattern, and so this is what I have as input information.
The first one is 1, and the second is 2, third, 3, fourth, 4.
Yes. Okay, so I'm seeing this number here, which was the bottom part, right, is always the same as where we are in the pattern. So I could represent that with a variable, right?
Yeah.
All right. We can use n. I like n. So I'm going to have n times something. Now I need to find a relationship between these two numbers. Because I know that this number right here is the same as this. So if I can find a way of relating these two together, then I can see how to relate this here. How do 4 and 8 relate? 3 and 6, 2 and 4, 1 and 2. This is what I have as my input.
It's multiplied by 2.
Multiplied by 2, it's twice as big each time, right?
Yeah.
Alex, I think you mentioned that already, right? That it's twice as big? How do I say that it's twice as big as this number?
N times n.
Not n times n, that would be a square. N times 2, because it's twice as big. So I can do n for this part, n times 2 for this part, and then plus 2. Could you use that information now to tell me how many there are in the 43rd pattern?
You put 43rd and n times 2.
Yep, so I would do 43 times what?
2. I mean, n. You lost me.
2n.
Oh.
What is n here?
43.
43. So what is twice 43? 86.
Oh, that number.
Because that is 43 times 2 to get this. And then what would I still need to do?
Plus 2.
Plus 2.
Yeah, 37,000.
Read the numbers off.
3700.
Perfect. 3700 flowers. All right. Do you guys want to do something else off the review, or do you want to look at another pattern?
Something off the review.
Something off the review? All right. Most of number 2? Do you guys want to look at number 2?
Yes.
Okay, let's go look at number 2 then. Nope, that's not what I wanted. I want this. Come on. Kayleen and Hezekiah decide to host a 5K. It will cost them $500 to rent the roads from the city, and it's going to cost $7 to get custom t-shirts for each of the participants. Let's write this in slope-intercept form. What is slope-intercept form?
Y equals mx plus b.
Y equals mx plus b. Which pieces will we replace with numbers?
M and b.
M and b. What does M represent?
500.
No,
I mean,
the 7.
oh, 7.
7, because why?
This is starting. No.
M is the slope. This is our rate of change. I would be looking for a keyword here for each, for every, per, showing me that it's occurring over and over again. What does B mean here?
The starting.
Starting amount, the initial, the y-intercept, starting initial. What is the initial amount?
500.
500. They just have to pay that one time, and they have to pay it up front. So what is the rate of change? What is the thing that's going to happen over and over and over?
The y equals 7x plus 500.
Yes. $7 for each participant. So we're going to have y equals what? 7x plus 500. Yep, part A, that's all I want, is just the equation. Part B, what does the slope represent in context? So what does the 7 mean?
$7 for a t-shirt.
$7 for t-shirt, so you just buy one t-shirt and you're good? For each participant, so $7, increase or decrease?
Increase.
Increase in cost for each participant's shirt. What does the y-intercept represent then? Yes. The $500 upfront cost. They only have to pay this one time. To rent the roads. If Kayleen and Hezekiah charge $30 for each participant to be a part of the 5K, how many participants do they need to break even? So up here, this equation is how much it's going to cost, right? Down here, they're saying that they're going to be charging money. If they're charging money for something, does that cost them money, or are they going to get it?
You're gonna get it.
It's going to be income. So let's write an income equation. Y equals 30x. Why 30x? Because that's the charge for each. And then you could pop a plus 0 on the end. Why plus 0?
Oh,
Yeah.
they can't get any more.
They don't have a starting amount, right? It's not like they already have money that came in as income. Nobody gave them a donation. They're going to get $30 for each participant that's coming in. So you can put the plus 0 on there. You can leave it off. It's up to you. The reason you have a choice there is because plus 0 isn't going to change my value at all. I want to know where these break even. What would I do with these two equations if I want to know where they break even? Set them equal to each other. Break even is another way of saying when are they the same. All right, so I'm going to have 30x is equal to 7x plus 500 minus 7x on both sides. Yes. 23x equals 500. And I'm going to need a calculator for this part because I don't know that off the top of my head. $21.73. But what does x represent here? The people. Can I have 0.73 of a person? 22. Would 21 be enough participants to break even?
No.
No. I'm going to have to round it up. It means we're going to have a little bit left over. Cool. We make some money for our charity. So 22 people. If they have 45 participants, will they have a loss or a profit? Profit. How do you know?
30.
How many people did they need to break even?
22.
22. Do they have more or less than that?
More, the last.
How many participants are there in Part E? 45. Is that more or less than what they need to break even?
Already more.
That's more than what they need to break even, which means they have more than broken even. They're going to get more money now because they only have to pay $7 for the shirts for each people that participates, but each person that participates has to pay how much?
30. No.
30. All right, so they're going to have a profit. Says of how much and explain how you know. So let's find how much the profit is going to be. Let's look at our income equation. If they have 45 participants, how much will they get? 45 times 30, which is,
1,950.
you said 1,250? 350, sorry. This is their income. And now let's look at their cost.
Their cost is only $315.
Their cost is only $350. We have 7. You said 315?
Yeah.
Sorry, I misheard you.
Oh, wait, plus 500.
315
315 plus 500.
plus 500.
815.
So cost is $815.
Yes.
So how much profit are they going to have?
8.
Tell me how you got that.
So by subtracting 1350 and
1350, that's their income, minus 815, that's their cost. I got $535 in profit. Are there any other problems that you guys want to talk about or look at? We still have about 10 minutes, so that's plenty of time to work through a problem. Maybe 2. Yes, sir. Yes, you may. The exponential problems? All right, let's figure out where the exponential problems are. Can you grab the bathroom pass out that I've given you? Thank you. You're welcome. Give me a problem number so I can jump there easily.
5.
Number 5. Sounds good. Awesome. Diana works at Kroger for $8 an hour. Madison is a DoorDash driver who has calculated her pay in the table to the right. So this is Madison's money. And then Diana gets $8 an hour. Write an equation for Diana. What's Diana's equation going to look like? What form should it be in? Slope-intercept form. So I need to write a y equals mx plus b form. How do we know that it's slope-intercept? Yep. She gets $8 for each hour. They're going to add $8, add $8, add $8. When you see this pattern of repeatedly adding the same amount over and over, that's going to be a y equals mx plus b. That's going to be a linear function. All right, so for Diana, I need a y equals what?
Can we pick any number?
No, I'm looking at Diana's information. This is Madison's over here. I want Diana's.
Y equals A plus 8x
8x
plus 60.
plus, so $8, that's right here. Each hour, an hour, that's right here. How much did she start with? Or how much did they give her up front just for showing up? Nothing. So plus 0. They don't give her any money just for showing up that day.
We need to.
I would love it if they did. I mean, they will give you money because you showed up and you clocked in, but they don't just like, I'm here, and before you clock in, they're like, thank you, you have $100. That'd be wonderful, but they don't. All right, so there's Diana. We need to write an equation similar to this for Madison. So how am I going to do that for Madison?
Same thing.
Same kind of thing. How much is she getting paid each hour?
It's all. It's $32, then $39, and then $50.
How much did it go up by here? How much? 7 something. 7 what? 725. For how many extra hours? For 1 extra hour, right? From 3 to 4 hours, she got an extra 725.
And then 2.
And then here it went up 2 hours. For an extra 2 hours, she got how much more? How much more did she get for working 2 more hours? How much? 14.5. If she got 14.5 for an extra 2 hours, how much did she get each extra hour? 14.5 was for 2 hours, right? So how much did she get for each hour? 7.25 for each hour. Was that the same as when she added an extra hour to go from 3 to 4? Yeah. So how much does she get paid an hour? 7.25. So y equals 7.25. X. I can't just assume that it's plus 0 here. With Dayana, I could, because they told me she makes $8 an hour, and I got no more information than that. When I've got this table, for all I know, with Madison's DoorDash job, they do give her money just for clocking in. And then she gets $7.25 an hour. I don't know. How would I figure that out?
Oh, it's 10.
How do we find that out?
You multiply the rate by 3, and then subtract that by
Here we go.
the per hour.
7.25 an hour. Oh, lovely. Got something on my shirt. For 3 hours, so 3 times 7.25. What'd you get when you did that? 3 times 7.25 was 10?
That. Right on.
21.75. But she got how much?
She got 31.75.
She got 31.75. So 31.75 from the table minus 21.75 means that she got $10 just for showing up. I am totally okay if that is the way you approach this. There is a more algorithmic way, formula-based way of finding this. If I was going to use a formula-based way of finding this, I would say y equals mx plus b. I'm going to grab some numbers off the table. In this case, Alex picked these two. 31.75 is what she got. We know the hourly amount is 7.25. She worked for 3 hours, and we're trying to find B. So we end up doing the exact same operations that we just did off to the side, but we're using more of a substitution approach here. Notice I'm still going to subtract 21.75 from both sides. And we get 10, just like we did with our side work. So 10 equals B. So I know this is going to be plus 10 here. I wish I had more room too. We want to create a graph that represents how much money they're going to make. Can we answer part D though? Who's going to make more money for working 8 hours? How do I find out? Yep, I can substitute in Dayana for 8 hours. Y equals 8 times 8. How much would she get? $64. So there's Dayana's amount. Madison. $68. $7.25 an hour for 8 hours. But remember, she gets that little bump. She gets that extra 10. What is the 7.25 times 8? 50, 58 plus 10. So she gets $68. So Madison makes more. bell's going to ring in less than a minute now, so I'm going to hold off, and I'll do part C at the very beginning of class tomorrow. Guys, before you leave, it is really important that I remind you of this particular piece. When does our final exam in here start?
Friday.
Friday is the multiple choice portion. Tuesday is the short answer portion. So we've got it split into two parts. I will not see you between Friday and Tuesday. I will not see you guys on Monday. If you have questions between Friday and Monday, you can send me messages in Canvas, or you can come see me during your study period, 5th period on Monday. So multiple choice this Friday. We got one more day of review together, and then it's the multiple choice portion. All right? I will have the answer key up so that you guys can look through that, and I will post videos from this class and from my 7th period class for today and tomorrow.